Hello and welcome to Chapter 5, Elasticity. I want to let you guys know that depending on the version of handouts that you have downloaded and have in front of you, I took out some slides from this PowerPoint presentation. They're not important, so if you do have additional slides in your handout, go ahead and skip them. Elasticity can be a little bit of a confusing topic, so I want to start out with a scenario that is going to explain why it's very important and necessary. Okay, pretend that you have a business and whatever it is you sell for $200 per unit, and you sell 12 of them per month. You want to know what happens if you raise the cost to 250. What will happen to total revenues and total profits? We learned last lecture, law of demand, that when I raise the price, I know for sure that quantity will decrease, but I want to know if quantity will decrease a lot or a little bit, because that will make the determination as to whether or not I am making more profit or less profit. All right, so let's jump in. Elasticity. The basic idea is that how much one variable responds to changes in another variable. In this class, the only really kind of elasticity we're going to look at is we're going to see how much quantity changes when we change the price. Okay, so that's definitely what we're going to do here. And it will give us a number of the responsiveness of the quantity to price. Okay, we'll also look at two other ones right at the end, but mostly I want you to think about how Q changes when P changes. All right, so here's the price elasticity of demand. How does QD, the quantity demanded, respond to a change in P, the price? The formula, write this down and memorize this. Percentage change in QD over percentage change in price. So simply, it's easy to find the percentage change in QD, and then we divide it by the percentage change in price. Okay? Loosely speaking, it measures the price sensitivity of buyer's demand. I want you to realize that the best way to understand this is pretend this changes by 1%, okay? Whatever number I get from my price elasticity of demand will just answer the question, when I raise price by 1%, when this goes up by 1%, how much percent does the quantity drop? Okay, so that's the basic answer that elasticity is measuring. If you keep that in mind, the definition of elasticity, it will make things a whole lot more easier. Okay, so look at this. Price is rising by 10%, quantity falling by 15%. We just divide the change in quantity divided by the change in price. It's 1.5. Using the definition, okay, if price goes up by 1%, if this goes up by 1%, then it means quantity will go down by 1.5%. Now, we always know that quantity will go down when price goes up. That's the law of demand. We don't need to worry about putting a negative sign in front of that. Okay? We would drop the minus sign, as I said before. So in your math class, probably in 9th or 10th grade, you learned that in order to find the percentage change, you just take the end value minus the start value divided by the start value times by 100. Okay, so here's how we compute the change in price. We go from 200 to 250. Okay, so that's change in 50 divided by the start value, which is 200. That's where we get this is my 50 and this is my start value. It equals 25%. All right. But the bit of a problem is that if you do it the opposite direction, it gives you different numbers depending on where you start. So just do it yourself. Calculate the elasticity from A to B, and then calculate the elasticity from B back to A, and you'll find that they give you two different numbers, which is kind of a problem. So we take care of that problem by calculating by the midpoint method. So instead of dividing by the starting value, which is traditionally what you do in math, you're going to divide by the midpoint, or the average value, the average between the end and the start value. You just pick the number between end and start value, and you divide by the midpoint. And this will give you the exact same value for elasticity, whether you're going up or down. Okay? So let's go ahead and do that. So again, from the same problem that we had before, we had $250 and $200. What's the midpoint between the two of them? It's 225. Okay, so it's 22.2%. The change in price. The change in quantity, it changes from 12 to 8, and the midpoint, the number in between 12 and 8 is 10 right here. So then we have an elasticity, a change in quantity of 40%. Remember, the elasticity is just the change in Q divided by the change in price, so that gives us 1.8. The definition of, using the definition of elasticity means that if price raises by 1%, then quantity will drop by 1.8%. If price raises by 1%, quantity will drop by 1.8%. Remember that, please. All right, so let's calculate this elasticity from these 2 points. All right, go ahead and do it on your paper, and then hit play when you are done. Okay, quickly, let's go over this. 5,000 to 3,000 was a change in quantity. The midpoint is 4,000. So that's why I'm dividing it by 4,000. I get 50% change in price. Change in quantity is 50%. Change in price, it goes from 90 to 70. The midpoint of 90 and 70 is 80. That's 25%. I simply divide those, and I get 2.0. So using the definition, if this 2, what it means is if price goes up 1%, then quantity will go down 2%. That's very important. If price goes up 1%, quantity goes down 2%. All right? So what determines price elasticity? So suppose prices of 2 goods rise by 20%, and we want to know which has the highest price elasticity of demand, meaning which good falls the most, okay? Clearly, if you think about differing goods, if price changes, some goods people are going to keep buying no matter what the price. Some goods people are going to stop buying them. That means they're going to have a very high elasticity. So let's talk about some reasons. Okay, breakfast cereal versus sunscreen. Let's think what happens. Breakfast cereal, the prices rise by 20%. People are going to stop buying breakfast cereal, and they're going to switch because it has substitutes. Sunscreen, however, people still need sunscreen. They're going to go out in the sun. So if it goes up by 20%, people don't stop buying it. Okay, so the change in quantity on sunscreen is going to be very low. Think back to the formula. It's a percent change in quantity over the percent change in price. If quantity, the change is nearly 0, that means elasticity as a whole is going to be nearly 0. All right, so memorize this. Price elasticity is higher when substitutes are available. All right, blue jeans versus clothing. Okay, if price of blue jeans goes up, people will switch to other types of pants. But if price of clothing in general goes up, people still have to wear clothes, so that quantity will not change. Remember this. If I narrowly define my good, like blue jeans, the price elasticity is very high. Broadly defined ones, such as clothing, is not high. Okay, insulin versus Caribbean cruises. Think about this. If the price of insulin goes up, people still have to buy it. Otherwise, they will suffer health consequences. So insulin is inelastic. They will not change buying it. But the quantity of Caribbean cruises, because that is a luxury good, people will stop buying it. Okay, remember this as well. Luxuries have higher price elasticity than for necessities. Okay, short run versus long run. What do you think? In the short run, gasoline will increase. The price of gasoline increases. You know what? I still have to buy the same amount of gallons every single week in the short run. So the elasticity is close to 0. In the long run, all right, I'm going to buy a smaller car or a bicycle. I'm going to get rid of my gas-guzzling SUV. So my price elasticity is very high in the long run. So in the long run, it's always higher than in the short run. Okay, so here's a nice quick summary on the determinants of price elasticity of demand. All right, so let's look at a couple of demand curves here. Now, if you're thinking about demand curves that we learned about last chapter, you will understand that this slope or the steepness of the demand curve has something to do with elasticity. Remember, it's not exactly it, but here's some rules of thumb. Okay, if the demand curve is straight up and down, the change in Q is going to be 0%. Let's just suppose the price changes by 10%. Q is going to change by 0%. All right, so you see that no matter what change we put down here, we always get 0 up here, which makes this whole fraction, 0 divided by anything, is always equal to 0. So the elasticity, of course, here is The elasticity is therefore 0. Here's a pretty steep demand curve. So let's go ahead and pretend the price falls by 10%. We see quantity changes by a little bit, but less than 10%. It's a small amount. So something smaller than 10% up here, something smaller than 10%, okay, divided by 10% is going to equal something that is much less than 1. All right. Now here we have something that is not as steep. Just for convenience sake, it's drawn so that when price falls by 10%, quantity rises by exactly 10%. We have elasticity exactly equal to 1. All right, and we're getting even flatter now. If our price falls by 10%, look at this graph. You can tell that quantity will rise by more than 10%. So think about this ratio right here. This number is bigger than 10. This number's 10. So that's going to be something greater than 1. All right, and finally, if it's completely flat, price cannot change. It's going to be 0%. So if I have anything divided by 0, all right, that's going to give me an undefined number of infinity. All right, so it's very, very high. All right, so here's some elasticities from the real world. I want you to see that these things here, eggs and healthcare, no matter what the price changes on these things, people are still buying that same amount. Restaurant meals and Mountain Dew, they're very sensitive. If price rises just a little bit, the quantity of restaurant meals and Mountain Dew goes down. A good way to think of the elasticity is it goes from 0 all the way to infinity. Okay, the number for elasticity go from 0 to infinity, and the middle point is 1. Okay, stuff down here is inelastic, stuff up here is elastic. It runs from 0 to infinity, and the midpoint is 1. All right, so let's look at the elasticity of this linear demand curve. The slope is constant, but its elasticity is not. This is really important. Remember this. The slope may be constant, but the elasticity is changing along it. Let's just go ahead and calculate. Right here, if I change from $30 to $20, the change in quantity is 200%. The change in price is 40%. That's the elasticity of 5.0, meaning up there stuff is very elastic. All right, if I change in this middle spot, it is exactly 1, so it's that midpoint. And then down here, it's going to be very low. So this is down here is, on all demand curves, it's the same. The lower portion of the demand curve, the lower portion of the demand curve is inelastic. The upper portion is going to be very elastic, and there's going to be some sweet point right in the middle where the elasticity is 1. That is known as unit elastic. When elasticity is equal to 1, it's unit elastic, and that's kind of like the midpoint of where the numbers in which elasticity can lie. Remember, it goes from 0 to infinity, and the middle point is 1. So let's think about total revenue, because ultimately the whole point of finding elasticity was to answer this question. If you remember from the beginning of the chapter, we're not calculating this just for the fun of it. We're calculating this because you are pretending that you have a company and you want to know if you raise the price, will revenue rise or fall? Okay, so remember, revenue is just price times quantity, and a price increase therefore has two effects. If you increase the price, you get more dollars, but you get less Q because of the law of demand. So we want to know which of these two effects is bigger, and it depends on the price elasticity of demand. So here's a review of the things you need to remember. If demand is elastic, this means that price elasticity of demand is greater than 1, okay? So what does this mean? That means that this up here must be bigger than this right here, because if you're taking this number and dividing it by this number, you're getting something greater than 1. This is telling you greater than 1. So the change in quantity must be bigger than the change in price. So if you change price a little bit, quantity is going to drop a bunch, okay? And you're going to end up losing money, okay? If price elasticity of demand is greater than 1 and you raise the price, the quantity is going to fall a lot and you will end up losing money, okay? So you will have less revenue than from before. Okay, so just pretend that the elasticity of demand is 1.8%. That means every 1% price goes up, quantity falls by 1.8%. So right here at this point, revenue is $2,400. If I increase it to $250, that's going to mean that Q falls to 8, and my total revenue is 2,000. Okay, so I am making less revenue than before, and I figure this out from elasticity. So that's my lost revenue from people who don't buy, less Q. This is gained revenue due to higher P, but you can see the yellow rectangle is smaller than the blue rectangle. The gain from higher P is less than the loss due to the fewer people buying. So when D is elastic, remember this, a price increase causes revenue to fall. Anytime that you're at an elastic point on the demand curve, you should lower your price. Let's think about what happens if price elasticity is less than 1. Okay, so just think about what's happening here in math. This number must be smaller than this number because when you're dividing, you're getting a small number. So that means you can change price a lot and quantity will not change that much. Okay, that means you go ahead. You're trying to make a profit as a business owner. Raise price as much as you can because you're going to be making more revenue. Okay. Suppose that Q only falls to 10 instead of 8 when you raise your price to 250. So I have a steeper demand curve drawn. The elasticity is 0.82. Here are the two revenue. In case you're not understanding how we're calculating the revenue here, it's very, very simply P times Q. So if I'm selling for at $250, I'm selling 10 units. That's the same thing as finding the area of that box. The area of this box is the revenue, 250 times 10, and that's where we get $2,500 from. Okay, that's how I'm finding my revenue. If I compare those two, it's actually true that the lost revenue is less than the increased revenue due to the higher P, so overall, I am making more money because I can raise my price when it's inelastic. This makes sense. If people aren't going to change their buying habits, their Qs, then keep raising price as much as you can and get as much profit as revenue and profit as you can. All right, I want you to answer these questions, and think about what we've talked about if revenues will rise or fall. And when you're done, I'll give you the answers. All right, for insulin, it is inelastic, so expenditure rises. For cruise, we know it is going to be an elastic good, so revenue is rising, okay, when the price of a luxury cruise goes down. Remember, when your demand is elastic, you want to drop the price. That's what this example is showing us. Okay, just as demand has a price elasticity, supply, the quantity supplied will also have a price elasticity. It's the exact same formula, except instead of looking at QS or QD, we're going to look at quantity supplied right here. Okay, it measures seller's price sensitivity. Again, the formula, the definition of this formula is if the price goes up by 1%, whatever number you get for elasticity will be how much percent that supply increases. We're going to use the midpoint method to compute percentage changes. Now here the only difference is elasticity of demand was always a negative number. It was always going down because we know demand curve slides down, so we just threw away the negative sign. Here for price elasticity of supply, it's always a positive number, so we don't have to worry about getting rid of a negative sign. Okay, so let's do this really quickly here. If price raises by 8%, quantity rises by 16%, that means that price elasticity of supply equals 2%. Using the definition, this is going to tell me that if I raise price by 1%, okay, that means suppliers will supply 2% more. If I raise price by 1%, suppliers will supply 2% more. So here's some supply curves, and we're going to talk about what the elasticity of these supply curves are. Think about this. What's the change in Q here? There's no change in Q. No matter what the price is, the change in Q is 0. So this could be, 100. It doesn't matter. Overall, oh, that's a horrible looking 100. Overall, try to do this a little better here. There we go. Overall, the price elasticity for this guy is 0, and we call that perfectly inelastic. Okay? An upward sloping curve, it's, we call this inelastic. Elasticity is less than 1. In this example, price rises by 10, quantity rises by 10%, elasticity is exactly 1. Okay? In this one, it's getting flatter, so the quantity raises by a whole lot more than the price does, and I have something greater than 1 for elasticity, and perfectly elastic, okay? Anything divided by 0 is infinity. Exact same concepts as the demand supply. Remember, again, elasticity goes from 0 to infinity, and 1 is kind of the middle point. All right, so let's talk about what determines supply elasticity. All right. It basically comes down to the point of how easy it is for the firms to increase supply. Some things are just necessarily very inelastic. For example, oil refineries, it takes forever to build an oil refinery. So an oil refinery always has to run 100%, and it takes a very long time to build another one. So the quantity of supply for an oil refinery is always very, very similar, very inelastic. Okay, so look at this. The supply of beachfront property is inelastic. The supply of new cars is elastic. Why is that? It's easy to make more new cars or fewer new cars each year. Beachfront property, it's hard to make more beachfront property. There are no more oceans or beaches being created right now. All right, so we're going to see which product will P change the most, and which product will Q change the most. Okay, so let's look at this. We're putting the two curves together in an equilibrium, just like we learned how to do last chapter. So here's really the fun. We get to put together everything that we've learned so far. I'm going to go ahead and have an increase in demand, and boom, what happens? Because the supply curve is inelastic, that's why it's drawn straight up and down, the price goes up a lot. The quantity doesn't go up that much. All right, this makes sense. If more people want beachfront houses, there's no more beaches to have, so really all that there's no more beaches to be had, so all that ends up happening is the price goes up, okay? But look at these new cars, all right? My demand curve slides up. The price doesn't go up a whole lot, but really, the firms just make more new cars, okay? Does that make sense? Along the same supply curve, though, I want you to see that the elasticity can vary. Down here at the bottom, the elasticity is greater than 1. It is very elastic down here, okay? But then way up here, the elasticity is less than 1. Okay, so just like I drew on the demand curve, this region down here is typically elastic. This region up here is typically inelastic. Okay. And there's a sweet spot in the middle where the elasticity is exactly equal to 1. All right, 2 real quick other elasticities, and then we'll be done with this lecture. Income elasticity of demand. Everything is always looking at how quantity is changing, and then the only thing that is changing is this whatever's down on the bottom. Here we're just asking, as income changes, how much does quantity demand change? Now this makes sense. If I get more income, I'm going to be able to buy more things, and if I want to know exactly how much, I can refer to the income elasticity of demand. Now this elasticity actually goes from negative infinity to positive infinity, and 0 is the middle point, okay? Because inferior goods have an income elasticity less than 0. There's this other type of elasticity, cross-price elasticity of demand. I just am wondering how much does QD for my good change. That's this up here. Remember, it's always QD on the top. But then the price not of its own good, this is of a different good, okay, of cross-price elasticity. So this elasticity also goes from negative infinity to positive infinity, and the middle point is 0. The rationale there is substitutes have a cross-price elasticity of greater than 0. Complements have a cross-price elasticity of less than 0. Okay, and that's all you need to know about elasticities.